Alright, in this video I'm going to show you how to use a tensile extensometer while we use the Insteron 3382. This is a 1-inch extensometer that we're going to use. So this is an add-on to the videos that you've already seen on tensile testing with this piece of equipment. So what we're going to need for this part of the video is we have our extensometer, and I'll show you more about this later. We have our Insteron 3382 all set up with the proper grips. We've got our sample that we want to test, and that's basically what we need. So I'm going to show you kind of all the alterations to the tensile test that we would need for using the extensometer, because in the other videos you've seen it without that. And if you're wondering about the extensometer, this is used to very accurately measure the extension during the tensile test of the region in the reduced section that you're clamping to. So it's a very accurate way of measuring the extension as opposed to measuring it by the cross set up here. So it's just a more accurate way of measuring that. Alright, so I'm going to walk you through what we need to do. The first thing we need to do is hook up the extensometer before we start the program on the touchscreen. And then we are going to load the sample up like we would normally do, and we're going to attach the extensometer. And then I'm going to show you the test because during the test it'll prompt you to remove the extensometer so it doesn't get damaged. So I'll show you all these steps here in the video as we learn to use this extensometer. Alright, so that first step, we have to attach the extensometer to the machine through the portal back here. So we'll reset, and I'll show you how to attach the extensometer. Alright, so we're over here on the side of the Insteron here, and we're at the control panel here to connect the extensometer. So I've got it here. So you'll see the actual extensometer here. This is what it looks like. And this is the connection that we want to connect to the Insteron. Alright, so this is going to go into what you see as strain 1 right here. So all we have to do is hook it up to here. Make sure you have it on the right. Alright, and then it should click in place, and these things prevent it from coming out. So now it's hooked up to the machine, the Insteron, and so at this point, again, this was all done before we start the Insteron program, Blue Hill, and so we are ready to go ahead and start the machine and start loading our sample and attaching the extensometer to the reduced section. Alright, so we're over here at the Insteron computer now, and we're going to start the software as we normally do by the Blue Hill Universal. That's the help. So we're going to go down here. This is actually Blue Hill Universal. So this is the shortcut to the software. So we're going to double click it or click it once on the touchscreen. So this is just like you would any other tensile test. And it's going to start up the machine. And you might have heard that click. That's kind of releasing the safety mechanism so that we can move the cross set. We're going to put in the login information, and you can find this in the lab or ask any lab personnel for that information. And we're going to go to test. We've already got a method created, and what we're going to be looking for is one of the programs with the extensometer already set up to use that. And I might have to move in a little bit here so you can see that. But right up here, this is called Steel 4140 Tensile with Extensometer. And so we're going to use that test because that's the one built for the extensometer. Alright, so that's the main difference. You just want to make sure you use the program or the method that has the proper information. We would input data just like we have before and follow along with the steps. So we are going to do that. So I'm going to kind of assume that these are all the length, width, and thickness is okay. We can set the rate. Right now it's set at 2.54 millimeters per minute, and we've got the length. We can put a label on this as well. So we'll just call this 4140 test. It's called Extensometer. All right. And effectively at this point, we're done inputting all the information, and so now we need to, wearing our safety equipment, put the sample in, and we need to zero the extension and balance the force. So we're going to do the balance the force part first, because we want to do that without a sample in there. And so if I go down here and we reset this, so it might be a little hard to see, but there's a balance force button right down here in the middle. So if I click that, the force up here, which is hard to see, but that should go close to 0. And right now it's 0.04 or so newtons, so it's a small amount. So there you can see a little bit better. So we've zeroed the force. And so after we have the dog bone set up in the apparatus over here, we'll do the zero extension and set that up. So I'll reset and put the dog bone in. All right, so now we're set up. We've got the sample in the machine. I went ahead and zeroed the extension. And now we're about ready to set up the test as we would before, but we need to put on the extensometer, which I've got here. And if I just come a little closer to the screen, just to kind of show you how this works. So basically, this will attach each one of these pins or clips will be attached to our sample, and when the sample moves, this will move with it. So you might be able to see it deflect a little bit. So you can kind of see that deflect. So whenever this moves, you'll get a reading through the extensometer. So it's a very accurate way of measuring the extension in this specific distance, and so that's the reduced section. This is roughly 1 inch in English units. So basically what I'm going to do to install this is I'm going to pull back these clips, so maybe you get a better view of that. I'm going to pull these back, and then I'm going to insert that onto the reduced section of the tensile dog bone. So when I do that, I'm going to zoom in a little bit so you can see it better. Alright, so we're ready to put the extensometer on. Again, this is the extensometer. And what we're going to do is, what we always have to do when we're installing this onto the specimen is we will need to push these two pieces together. So this sets it at the initial gauge length. And so if we have these pressed together, it won't move. So the whole time we're holding this with, for me, it's my left hand. And then what I'm going to do is I'm going to use 2 fingers on my right and pull them back so that we can open up these clips. And so this knife edge will be pressed against the flat sample, and then when we let go, the clip will hold it to the knife's edge, and then I can let go, I can let go of this, and it'll be ready to move when we start our test. So I'm going to start by holding these, and then I'm going to, again, pull these back. And I'm going to let go now that I have it clipped on. So you might not have been able to see that all, but the knife's edge is now on my reduced section. And then I've let go of the 2 prongs so that it could now move. And the other thing you might notice is that with our setup here, for our grips and the extensometer. The extensometer is actually pretty tight in there, so you might have to rearrange the sample, not grip as much of the shoulders to be able to allow enough room for the extensometer's body to fit between the grips. So that's just one consideration that you might have. But that's basically what we needed to do. We've got the extensometer on now, and we're ready to test as we would normally test this sample. So I'm going to close up the safety shield and start the program, and then I'm going to show you what happens after that. All right, so again, we have everything set up on the load frame. We have the sample installed. We have the extensometer installed. There is a force from tightening the grips, so there's a little bit of a force here. And we also need to make sure that the displacement is 0. So after you put on the extensometer, you'll have to hit the 0 displacement as well. And so that should be 0 as it says right up here. All right. At this point, we're ready to go. And so we're going to go ahead and hit the start. And the test should start now. And it's, you might be having trouble because of the glare seeing the curve here. There, I'll tilt it to the side. That works a little bit. And what we're going to see is, as I told you in the introduction, the extensometer only works to a certain distance, and then after that, you're not getting any usable data. And also, it's a very sensitive instrument, and so if it's on there while it breaks, that's not good for the test. So it's going to prompt us in the program to take off the extensometer at a certain point. And so that should happen before it breaks. So it'll come up with a dialog box, it'll stop the test, and then we're going to have to open up the shield door and then take off the extensometer. So you see that basically it says extensometer removal point reached. It's pausing the test so that we can remove. So we're at this point able to come over here, and so I'll just move this real quick. So I'm going to open up the door, and then I'm just going to carefully take off, hold the 2 buttons again, and then use my fingers to remove the clip, put it safely here to the side, and then close back up the door. And at this point, we've removed the sample, and so now it's going to, once we hit close, it's going to start the test again, and it's now going to proceed through the tensile test to fracture. So again, it's hard to see here. That little blip is caused by the removal, but you see that overall nothing's really been affected, and so this will continue to break. So it's not good to have the extensometer on while it breaks, so that's why we remove it. It's just a sensitive device, so we want to eliminate that stress on the device. So I'll stay here with this test until it finishes. And for reference, this is our 4140 steel. Before we've done any heat treatments, it's just a sample as received, and then we have machined to our dog bone specifications. So we haven't done any austenitizing or any other types of heat treatments. So this is just a test piece to show you the test. Might not be able to see it, but it's necking now. The force has gone down. You can see here, and there it's broken. So just like the other test, it will automatically stop the machine when it detects fracture. And so when that's done, we can just hit stop. And now what we're going to do is, just like we would with the other test, we're going to open it up take our samples out, do any measurements that we need to do, and so forth. But at this point, it's everything's the same as the Extensometer. That data will be automatically incorporated into the data files, so you won't even really notice that you have any extra data. It just automatically incorporated into. So those are some of the modifications we have to do to run or to use the Extensometer while we're testing a tensile sample in this Instron 3384.